Hello, and welcome to the batch processing tutorial. In this tutorial, I'm going to show you how to perform some very basic mesh processing operations over a 3D scan in order to prepare it for further retopology and using it in production. Then we will apply the same processing to 50 other scans automatically. wrap3 introduced a node graph approach. Instead of performing operations step by step, you create a recipe of what you want to do with a scan, and then apply the recipe to unlimited sets of scans with little extra effort. Okay, let's get to it. First, what I'm going to do is come over here to the graph editor and load a 3D scan using Load Geometry node. Just to save you time, I'm going to fast forward some long operations like mesh loading in this video. Okay, so here we can see a head scan. Let's turn off wireframe and rotate it 90 degrees around the x-axis. I'm going to call the node a scan. If I press my middle mouse button over a node, you can see some useful statistics. For example, we can see that the scan contains approximately 5 million polygons. The first operation I'm going to do is to check if my mesh topology has some problems and fix them. I'm going to use a node called Repair Geometry. If I come over here to the Editor tab, you can see two columns of statistics about the mesh. For example, this yellow number says that the mesh contains 3 non-manifold edges. As I go over here and zoom in, you can see that the bad edges are highlighted with the same yellow color. Let me toggle the wireframe so that we can see the problem. As you can see, most of the normal edges are adjacent to exactly 2 triangles. Now, if you take a look at the yellow edge, you can see that it is adjacent to 3 triangles. Many 3D processing algorithms like subdivision, decimation, and wrapping fail to work with such topology, and it should be fixed beforehand. The next line says that the mesh also has one singular vertex. If I go over here and zoom in, you can see another example of illegal topology. Whatever the problem, you don't have to worry about it because Repair Geometry node will fix it for you. Let me come back to the 3D viewport by pressing the Q key and turn off wireframe visibility. The next problem with this mesh is these disconnected noisy pieces that sometimes come from photogrammetry software. Luckily, I can filter them out using Select Small Components node. If I go to the Editor tab, I can see that all my small pieces have been selected. As I'm playing with a threshold parameter, I can adjust the size of the pieces I want to get rid of. As you can see, the output of the node has a type polygon selection. I'm going to use another node called Delete Polygons to remove all the selected pieces. I'm going to plug the geometry to the first input and the selection to the second input. If I click this blue button with Control pressed, it will hide everything but my current node. Now you can see that the mesh no longer has noise all around. The next problem that you might often notice in your scans is spiky vertices here, here, and here. I would like to repair the most spiky vertices while leaving the rest of the mesh unchanged. I can do that by using Remove Spikes node. Let me set the smoothness parameter to 80 and plug my geometry in. Now the problematic areas look cleaner while the rest of the mesh remains unchanged. Alright, the last processing operation I would like to show you is decimation. I'm going to come over here to the Parameter tab and change the triangles count to 300,000. Okay, now that the node has been computed, I'm going to come up here to my loading node and turn on wireframe. Now you can see that the mesh was decimated. Let me turn off wireframe again. The final thing we need to do is save the result to a file. I'm going to create a folder that will store my results. I'm going to call it processed. Now I'm going to set the file name processed 3 hash signs .obj. If I click the Compute Current Frame button, I can see my scan being saved to file. Okay, what we've done so far is a recipe of how we want to process the scan. If I were to process another scan, all I need to change is this file name over here. But wrap provides a better approach. If I go over here to the file name dialog, instead of loading a file, I'm going to select all of my 50 files at once. Here on the bottom you can see a timeline. I'm going to go over here and change the maximum frame number to 50. Now if I switch to the next frame, wrap will recompute entire pipelines for my next file in the list. Alright, looks really nice. Now I'm going to run processing of all my 50 models in batch mode. To do that, I'm going to come over here to Save Geometry node, and instead of clicking Compute Current Frame, I'm going to click Compute Frame Range. In a pop-up dialog, I'm going to set the last frame to 49, and I'm going to set a number of parallel processes to 2. Now we can click the Start button and let wrap do its job. Let me fast forward the video and come back when it's ready. Great! Wrap has just finished computation. Let's go ahead and check our output folder. Now we can see that all 50 files were saved to disk. I'm going to go ahead and remove all my nodes. I'm going to create a Load Geometry node again and select all my saved files. Now I can switch between the files and check if all the results have been processed correctly. That's it for this tutorial. Thank you for watching. See you in our next videos.